Welcome guys, let's continue with the gradients. Let's continue the lesson from the last video. Okay, we are going to exercise number 6, and y equals 4x minus 3 is the equation of a straight line. Find the equation of the line parallel to that line, 4x minus 3, that passes through that point. Okay, so we have a line that is parallel to 4x minus 3 and passes through that point. Okay, again, the equation of a line, of a straight line, is always y equals mx plus c, being m the gradient and being c the intersection of the y-axis. Okay, so now if the line that we are looking for is parallel to 4x minus 3, that means that the gradient must be the same. Okay, so the line I'm looking for, okay, it's y equals 4x plus c. Okay, we don't know in which point it crosses the y-axis, but we know for sure, if they are parallel, that the steepness, the gradient, the inclination is 4, okay, because they are parallel, okay, they never cross. So we just have to find the c, because if we find this c, we know that we have the equation of our line, okay, and for that they give us a point, okay. They say that this new line, it passes through the point minus 1, 0. Okay, let's then use that information to find out our c. Okay, so what I do is, if I know this point minus 1, 0 is in this new line I'm looking for, okay, what I'm going to do is just replace the values in my equation and find out the c. Okay, so y is 0, okay, and 0 equals 4 times x. X is minus 1 plus c. Okay, so what I have is that 0 equals minus 4 plus c. That means that c equals 4. Okay, I just throw the 4 to the other side. Oops, equals positive 4. I just throw the 4 to the other side and turn it positive. Okay, so my line will be what? My line will be the line that I'm looking for, y is 4x plus 4. Okay, again, the steepness is the same, is 4, and my c we just find out using that point that is 4. Okay, alright, so my equation is here. 7. Line L passes through those points A and B as shown below. Okay, we have a diagram there, and they ask us to find the equation of the line L. Okay, to find the equation of a line, I need my gradient and I need my c. Okay, to find mx plus c, I need my m and I need my c. Okay, so that's what they are doing here. They want us to calculate by one of the methods that I show you in the last video. They want us to calculate the gradient using that method. Okay, so basically is my points are x, I'm going to call it x0, y0 as in the initial point, and the other point is xy. Okay, my initial point is 1 minus 1 and the other point is 5, 7. Okay, using those 2 points I can calculate the gradient. I just do the y's, 7 minus minus 1, 7 minus minus 1. And for the x's, I'll do 5 minus 1. 5 minus 1. Okay? So 7 minus 1, that will be 7 plus 1, which is 8. 8. And 5 minus 1 is 4. Okay? That means my gradient is 2. Okay? If my gradient is 2, my line will be 2x plus c, 2x plus something. Okay? So use point A to find c. Okay? So I already know that y equals 2x plus c. Okay? And now they want me to use the point A, which is the point 1 minus 1, to find out c. Okay? It's very similar of what we did in the first exercise. Okay? So what we do is y, we replace the y by minus 1, because this is a coordinate xy. Okay? We replace the y by minus 1 equals 2 times x. X is 1. Okay? 2 times 1 plus c. Okay? So c will be minus 1 minus 2. Okay? And okay, let me put this in here. This is equivalent to have that c equals minus 1 minus 2, because this 2 is going to the same side as minus 1, and minus 1 minus 2 will be minus 3. Okay? So c is minus 3, so the equation of my line will be 2x minus 3. And there you have it. Okay? Very easy. Nice method to calculate the gradient. Yeah. Okay, let's move to the last one. A second line is drawn from the origin to the point 4, 6. Is this line parallel to L? Give a reason for your answer. Okay. L. L is the line there. Okay. That line has a gradient of 2. Okay. We calculate the gradient here. The gradient is 2. For any line to be parallel to that line, that the gradient must also be 2. Okay? I repeat it. For any line to be parallel to this line L, the gradient must be the same, must be 2. Okay? You cannot have two parallel lines with a different gradient. Okay? The gradient must be the same between parallel lines. Okay? So if they are asking, is this line parallel to L? Well, to see if the line is parallel or not, what I do is I calculate the gradient, because if I calculate the gradient and ends up that the gradient is different from the original gradient that I'm trying to prove that the line is parallel with, well, if it has a different gradient, it cannot be parallel. Okay, so if we already know that the gradient of our L line is 2, okay, so if let's calculate the gradient of this one. So we have 2 points. We have the origin, which is 0, 0, and we have the point 4, 6. Okay, and we know that the gradient is y minus y0 over x minus x0. Okay. This is my point x0, y0, and this is my point xy. My xy is 4, 6, my x0, y0 is 0, 0. Okay? So that means that my m will be 6 minus 0, 6 minus 0 over 4 minus 0. Okay? So my m will be 6 over 4, which is the same as having 3 over 2. Okay? And 3 over 2 is 1.5. Okay? 1.5 is a different gradient than 2. Okay, so 1.5. Those lines are not parallel because they have a different gradient. Okay, not parallel, different because different gradient. Okay, that's the way to do it. Yeah. Alright guys, I think we are done with this gradient thing. I think I covered enough exercises to show you how to do it. Just keep it on, keep practicing, okay? Subscribe if you like the video, thumbs up, give it a like, yeah. And see you in the next one, or I will keep it coming. Cheers.